So, binomial experiments. We did these last year. We did them all by hand, which was really, really tedious. So we're going to look at doing them by hand, but one of the things that we're going to be learning how to do is how to use your calculators to do a lot of the heavy work for us. Okay? Because there are actually some really easy ways you can do these on the calculator. Now, before we get to the calculator, though, I want to make sure that we remember and understand how this works. Okay? First of all, I want to highlight a few things here. There we go. That'll be good. Okay? So, we're talking about binomial experiments. All right? You have to have a binomial experiment in order to use this. All right? A couple of highlights of things that we need to make sure that we have are these. First of all, there can only be two possible results. Hence the binomial aspect here. Only two possible results. Success and failure. Now, success is not necessarily good and failure is not necessarily bad. It's simply, what are we looking to happen in this problem? That's a success. Okay? If we're trying to roll a 5, then rolling the 5 would be the success. Rolling something else would be the failure. Okay? All right? So, we have that, first of all. Secondly, we repeat this experiment in independent trials. Okay? Independent trials means that the probability of success that we use P for is constant for all trials. Okay? The probability has to stay the same every time. Okay? Also, since there are only two possible results, if P is the probability of success, then 1 minus P is the probability of failure. Okay? Because they have to add up to 100%. There's only two possibilities. Alright? Now, our random variable, okay, our random variable x is the total number of successes in the trial. Okay? So we're going to look at x being distributed binomially. And we're going to look at the notation here in a sec. Okay? But I want to point out a couple of examples. A couple that we're kind of familiar with, flipping a coin, rolling a die. Those ones are kind of the manufactured types of problems. But in real life, we have things where we're picking things out of a group, but we're putting them back. So it's possible to pick the same one every time. Okay? You know, what's the probability of picking one of you guys to come up here and do a problem on the board? If I put all your names in a hat and I pick a name out and I have you come up and do it, and then I put your name back in the hat, the probabilities all stayed the same because I replaced it back into the pool of possibilities, right? So, selection with replacement is one of those things where we can get a binomial situation. If we're picking a group, like if I'm picking 3 of you to do something, that would not be, because once I pick one of you, now everyone else has a little bit better of a chance of getting picked. Okay? Another one, and this is the one that really is the most useful, but is very easily forgotten or overlooked, is if you're given a statistic about a population, particularly a very large population, and usually one where we don't even know the total number of people in the population, we can use the binomial probabilities for that. So for example, if we know that 20% of the population of the U.S. falls into a certain category, if we're selecting people out of a list and seeing if they have that, they're in that category or not, okay, even though we're not going to pick the same person twice, we're not replacing them, there's over 300 million people So taking one person out is not going to change our probabilities, right? Because if we take one person out, I mean, if there were a change, it's like down to the millionths or tens of millionths of a percent.
It's a little bit increased.
Okay, it will, but because it's such a large amount, we could treat it as a binomial probability in that case. Okay? And partly we do it because we don't know the exact number. To figure it out exactly, we would have to know the exact population of the U.S., which we never know. Okay? So, those are the binomial experiments. Let's look at this a little more mathematically. Okay? The binomial probability distribution function. Okay? We have success and failure. Some of this is kind of repeated, but the thing that I want you to really note here is this function here. Okay? R is the number of successes. Okay? And you'll notice we have P raised to the R power. Let's switch over to a pen here. Okay? We have the probability of success is going to be raised to the power, okay, that is the number of successes. All right? But if we have that many successes, we're going to have the rest of them be failures. Okay? Now there's a total of n, so if our probability of failure is 1 minus p, then n minus the r successes will give us the number of failures. Okay? And then you have this part right here in the parentheses. Does anyone remember what this is?
The probability of failure? Or wait,
this right here. The parentheses with the n and the r in it.
I know what it is, but I don't know how to say it.
Another way of writing it is n choose r. That's similar notation. You're going to see it a lot, so get used to that. Okay? But this notation, notice it's not a fraction. There's no bar in here. It's just n over r. Okay? That's the same thing as n choose r. And that's known as our binomial coefficient. Okay? That's equal to n factorial over n minus r factorial times r factorial. Okay? That formula is in your formula booklet. And if you're allowed to use your calculator can calculate those itself. Alright, so they do give you a little bit of help in calculating those. Now, why do we have this? Okay, this is the probability that the number of successes equals r. Okay? Remember, x is our independent variable. In the binomial distribution, x is the number of successes. Okay? And here's some notation that you ought to be familiar with. We have x distributed binomially with parameters n and p. So those parameters, n is the number of trials and p is the probability of success. Okay?
What do you mean distributed binomially?
Okay, x, when this is called a binomial probability distribution.
Right.
Okay? So the number of trials are going to be distributed based on certain probabilities. Okay? The probability of x being 0, x being 1, x being 2, all the way up to n. So those values are going to be distributed according to the number of trials and that probability. And then to calculate each individual one, we're going to use this formula down here. Okay?
Wait, to calculate each individual what?
Each individual probability, like the probability of getting no successes, or 1 success, or 2 successes. Okay? Now, here's the situation I think will help us kind of apply this and see how this is working, okay? This binomial expansion, we have 9/10 plus 1/10 to the 5th, okay? And we have a situation down here, okay, where we have an archer, all right? We're shooting arrows, and this archer has a 90% chance of hitting a target with each arrow, okay? So he shoots 5 arrows. Determine the chance of hitting the target twice or at most 3 times, okay? First of all, let's explain, why does this binomial here model this situation? Okay. Oh, Isabel?
Because the first part is the 90% chance, and then the 1/10 is the 10% chance of not hitting the target.
Okay, so this is the probability of hitting it,
And then the other one's of not hitting it.
okay?
And then since they're firing 5 arrows, that's what the 5th is.
Okay, good. The 5, that's how many times think about this experiment, so to speak, is shooting an arrow. How many times are we going to repeat that? 5 times, because we're going to shoot 5 arrows, okay? So we're going to repeat it 5 times.
So that would be your N?
Very good. N equals 5.
I taught some of this in my PCH review.
Okay. Good.
Congratulations.
All right. So if I want to hit the target, okay, remember our formula, we had N choose R, P to the R, 1 minus P to the N minus R. All right. How would I calculate the probability of hitting the target twice?
So it would be, it would be 5 choose 2.
5 choose 2, good.
Then it would be, the probability would be 9 out of 10 raised to the second.
Okay, because we want it to hit twice.
And then it would be 1 minus 9 over 10
Okay,
raised to the third.
very good. So I have the 5 choose 2, and the reason we have 5 choose 2 is because those hits and misses could be arranged in a variety of orders. I could hit my first 2 and miss the last 3, or I could miss the first 3 and hit the last 2, or any mix of those. Okay?
Sorry, I don't know if we were supposed to learn something. What's choose 2? Like, I've never.
That's a combination, also known as the binomial coefficient. In that formula that I had given you, N choose R is N factorial,
Minus.
N minus R factorial.
Times R factorial.
Yep,
Thing.
okay. And you were in pre-cal honors 2 years ago,
Yeah.
so I didn't have you. Oh, wait.
No, you didn't.
No, I didn't have
I
you.
had Miss Hen.
Okay. So yeah, you didn't have that, but we can get you caught up. So.
How much attention do you need?
All right, so now we got to figure this out. Okay, so 5 factorial over 3 factorial times 2 factorial, because n minus r, 5 minus 2 is 3 factorial. Okay, and remember to simplify this. We're going to have, hang on here, I'll do the rest of this, 81 1,000ths, or no, sorry, 100ths. And this is going to be 1 1,000th. Okay?
Can we change it to decimal or is it to?
If you want, you can. Okay. But 5 factorial, if you remember, it's 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Whoop.
But can we use our calculators or so?
You can. I'm just reviewing so you guys can see it once.
They cancel
All
out
right.
the 3s, they cancel out the 2s.
These cancel. okay?
And then
Remember the
use-
bigger, hang on, remember the bigger of the factorials will cancel out a good bit of the top. So the 3 factorial cancels out everything from 3 on down. So you just have the 5 and 4 left, and then the 2 factorial is left. So that's 20 divided by 2,
10.
so that equals 10. So now I know I have a 10 times 81, so that's 810 times 1.
Wait, why is it by 81?
Well, I'm just putting it all together now, because 9/10 squared was 81 over 100.
Okay.
And then on my denominator, I've got 100 times 1,000,
1 million.
100,000. So I could cancel out some zeros, and I get 81 over 10,000. Okay, so there's my probability of this guy only hitting the target twice out of 5 times.
And then how you do that most 3 times is you would add the probability of hitting it once, the probability of hitting it twice, the probability of hitting it 3 times. And you add all those answers up.
Okay, once or twice or 3 times, or
0 times?
0 times. Don't forget the 0. Okay? So we would have to do this process here 4 times. Well, we already did it once, so we'd have to do it 3 more times for 0, 1, and 3 and add them all up. Okay? What's an alternative to doing that though?
Finding the probability of 4 and 5, and then subtracting
From
1.
1, okay? So this is going to equal 1 minus the probability of 4 or 5, which only finding 2 of them is going to be easier than finding 4 of them.
Yeah, but how do you know that?
Well, again, it goes back to the fact that all your probabilities have to add up to 100%. Okay? So you kind of think it's the complement, or you could think kind of like the opposite. What's the opposite of hitting at most 3 times? Well, hitting more than 3 times. Well, that would be all 4 or all 5.
Oh.
Okay? So you just kind of have to figure that out logically. Okay? And then,
Will you use the same formula to find if it's 1 minus b, or?
well, yeah, because you got to find the probability of 4, and you've also got to find the probability of 5.
But then you will subtract the answer, like we got, the previous, like in the previous one, we got like 81 over 10,000. That will subtract from 1?
No. Only the 4 and 5 will subtract from 1.
Yeah, but like their answer will subtract from 1.
Yeah. Okay. So yeah, so here we've got 5 choose 4 times 9/10 to the 4th power times 1/10 to the 1st power. Okay. For the x equaling 5, it's 5 choose 5. 9/10 is going to be to the 5th power, and 1/10 is going to be to the 0 power. Okay? So that's 1, and that equals 1 as well. So it's just 9/10 to the 5th power. Okay? And you guys can figure those out on your calculators and do all those. Okay? Does that make sense?
Yeah, next lesson, can you quickly review how it is that you put the 5 choose 4 in the calculator? 'Cause I forgot.
Yes. On Thursday, we're going to look at how to do all this on our calculators. And the nice thing about this is because then we can do situations where he's not just shooting 5 arrows, but say he's shooting 500 arrows. And what's the probability of hitting at least 400 of them? So we'd have to do 400 and 401 and 402 and 403 all the way up to 500. But your calculator can do it really fast. All right? I want to look at a couple of functions on the calculator that are really, really helpful. And this is one case where the Nspire is really nice as opposed to the 84. And it is also one case where having the 84 is significantly better than having the 83. Okay? If you have the 83, we'll talk about how to do it. It's not that much harder. It's just the 84 has one feature that's makes it a little bit easier on you. Okay, so here we have x distributed binomially. X is distributed binomial with n and p. Now n is what?
The number
The
of
total amount of
things
numbers.
can expect to happen.
Okay, the number of trials, we could say, okay? And P is the probability of success, all right? And remember, success is simply whatever we're looking for there. In the case of our archer, we're looking at hitting the target. That's success, okay? So
Number of trials would be 5.
the number of trials in that case would have been 5 because we had 5 arrows that we were shooting, okay? Now, what I want to look at here is how to do this on the calculator, okay? So, you'll see here on the TI-84, does anyone have the Nspire? Okay, on the Nspire, you're probably better off just typing in binom PDF, okay? PDF stands for probability distribution function. Okay? Since all of us have either the 83 or 84, if you look near your down arrow, you'll see the vars button. If you hit second vars, it says distributions. Okay, or it says DISTR. That stands for distributions. And you'll see a number of options. If you scroll down to letter A, you'll see binomial PDF. All right, I'm going to show you this here. Okay.
That's so neat, it's like live action. Wow.
Okay, so let's record this here. All right, so we have here, see right near the down arrow, there's distribution above vars. So we're going to hit second vars. You scroll down to letter A. Okay, binomial PDF. And you hit enter. And if you have the 83, it probably just put this on your desktop, and you got to remember what order to type things in.
Yeah.
If you have an 84 and it's doing that, you need to upgrade your firmware, and we can help you do that very easily. Okay? But you get this little menu, and you type in the number of trials, the probability of success, and then the X value. Okay? So our archer shot 5 arrows. He hits the target 90% of the time. And we're going to find the probability of him hitting the target exactly 3 times. Okay? So we just put in 3 for X, and we hit enter to paste it. And those of you with the 83, this is the order you need to type it in. N, P, X. All right? N, P, and X. So now you hit enter, and it does the binomial expansion for that term, and we get 0.0729. Okay?
That's the percent chance, right?
That is the percent chance. All right? And you can see right here, I have a little screenshot of that. Again, this is N, this is the probability, and then X is the number of times you want success. Okay? Any questions on that so far? Pretty straightforward. All right? We can also use this to find the range. A range of, let's say we want the probability of hitting it at least 3 times. Or up to 3 times. Something like that. Okay? This is where we have the binomial CDF. Okay? CDF. And this is where the 84 versus the Nspire does have a significant difference. Okay? The Nspire, you can see down here, it allows you to put the bottom of the range that you want and the top. So if I wanted at least 3, I'd put in 3 for X and then 5 for Y, since that's the maximum that he shot. Okay?
On the 84.
On the 84, it automatically starts at 0 and goes up to whatever you plug in. And that's where this can get a little bit tricky to make sure you're getting the right stuff. Okay? So by the way, when you're showing your work, writing out this on your paper is good for showing your work. All right? And that goes for on paper 2 of the exam as well. If you just write down the calculator function you're using, you can do that.
So
All right?
wait, so,
Yes. Sorry.
It's like really cold. Could we turn the?
Yeah, we can.
What the answer you got there is the probability of it being 1 times 2, 0 times 1 times 2 times and 3 times.
That's correct. Okay. Here, right here, because it's binomial CDF, this is finding the probability of up to 3 hits. Okay? So this would be the probability of him missing all 5, plus the probability of him hitting it once, plus the probability of him hitting it twice, plus the probability of him hitting it all 3 times. Okay? So that's what this is finding right here. Okay? Now, this is pretty easy because that's just a straightforward use of binomial CDF. And on the calculator, that's pretty easy. The binomial CDF was in the menu right below the binomial PDF. Just be careful that you hit enter on the right one. Okay? So, CDF is the second one. Where it can be a little bit challenging is when you don't want to start at 0. Okay? So, and this is what I want to spend a little bit of time looking at. Let's say I wanted the probability of at least 4 hits. Okay? Now, how could I figure that out?
You find the probability of 0 to 3, which is what we found, and we do 1 minus that.
Very good. I could do 1 minus the probability of up to 3.
But wouldn't
Okay.
you get too high of a number? You get like
why would it be 1?
0.92-ish.
Well, yeah. Okay. 1 minus that would give me 1 minus this, which would equal 0.91854.
Wait, I don't understand why we're doing 1 minus.
Can someone explain what principle are we using here?
But it has to add up to 1, right?
It's got to add up to 1.
But why are we doing -3 if we want at least 4?
Because here's what we want. We could hit it 0, 1, 2, 3, 4, or 5 times, right?
Yeah.
So if we want at least 4 hits, that's this. I know that all of this adds up to 100%.
Oh, and we know
So-
how much 3, so we right. Okay.
Exactly. This is what we found. So if we subtract that from 100%, all we'll have left is what we're looking for. Okay? That's not too bad. The thing where it gets really tricky, and this is where the Nspire is really nice because they have your starting and your ending, is what if we wanted the probability of, let's say, 2 to 4 hits?
Just do the PDF 3 times.
We could do the PDF 3 times. We could do the CDF up to 4 and then subtract the CDF up to 1, right? But again, it's getting a little complicated. I'm going to kind of abbreviate here, CDF with 5.9 and 4 minus the CDF with 5.9.
Sorry for the interruption.
One.
Jessica Chomnick in the classroom.
Okay, so we could do it this way, all right? But again, the thing that we mess up most of the time when we try to do it this way is we'll accidentally put 2 here instead of the 1, because we're thinking, oh, we want to go all the way down to 2. So we forget and we accidentally put a 2 here, so now we've just eliminated the 2. We're only doing 3 and 4, okay? Here's a nice way that you can avoid that issue though. And this is the thing where if you've got the 83, you're going to basically have to do it this way. Okay? Because summations are a real pain. If you can work it out and get comfortable with it, then the summations may be a good way to go for you. But on the 84, when you type in the sum, okay, we can do the sum from x equals 2 to 4 of the binomial, not CDF. We're going to find individual terms, right? So binomial PDF with 5.9, and then we're going to put x in here. And check out what this does. This is going to do the binomial PDF when x is 2, then the binomial PDF when x is 3, then the binomial PDF when x is 4, and it's going to add those up together. This is going to be a really easy way of doing that. And I want to show you how to do that here on the calculator. Let me get my calculator back up.
Just to be clear, the 83 can't do that, right?
It-
Or it's very
The 83 can, but you have to do go to second list and sum, and then sequence, and then put in your binomial PDF, and be really, really, really careful.
Oh, no.
So it's possible, but I think doing it the other way is just easier in that case. And that's where maybe for the exam, borrow an 84.
Okay.
Because, it's similar enough to the 83. It's not going to mess you up. Okay. Yeah, that might be better. All right, so to find the sum, you go to Math, and you scroll down to 0, okay? There's our summation. Hit Enter, and now it gives you this nice little template. The template's also on the Nspire, but the Nspire does ranges easily already, so we don't even have to do it that way. Okay, so now we're going to do x, and we wanted to start at, what do we say, 2 to 4? All right, so x equals 2, put 4 for our upper bound, and now we're going to go to our distributions inside the sum. So second distribution, we go down to binomial PDF. Be real careful. Binomial PDF. I want 5 trials. Each one has a 0.9 chance of success. But notice I'm going to plug x in for the x value, because my summation is going to plug in the different values, 2, 3, and 4. Okay? So now I can hit Enter, and you see it pastes it there for me. And now I can hit Enter, and it's 0.40905. So I have about a 40.9% chance of hitting the target 2, 3, or 4 times. All right? Oh, I didn't record any of that. But if you were listening, you can see it all right there. Okay. I always forget to hit record after I put the video thing on the screen.
Double record.
Yeah, I have a recording and a recording. It's like, what was that movie? The dream in a dream in a dream.
Oh, Inception.
Inception, yeah, it's math inception. Here we go.
Yeah.
That one.
Okay.
It's like that movie.
All right, any questions about using the calculator there, or? Okay, really powerful tool that you've got, okay? Make sure you know how to use it. But you gotta think through the logic, especially if you're gonna do the CDF of one minus the other. Just be really, really careful as you're punching those in, okay? Okay, let's at least set these ones up with the time that we've got here. 72% of union members are in favor of a certain change to their conditions of employment. A random sample of 5 members is taken. So here, our binomial probability is 0.72 plus 0.18 to the 5th, right? So we have five members that we're polling. Find the probability that 3 members are in favor of the change, okay? So we're gonna do binomial what?
Just to make sure it's 5, choose 3, right? No.
If we're gonna do it by hand, it would be 5 choose 3.
Minus 5, choose 2, and 5, choose 1.
No. Use our binomial.
Oh, times the, okay.
0.72 to the third and 0.18 to the second, okay?
Okay.
Now that's gonna do the same thing as doing what on our calculators? The binomial, which one? PDF or CDF?
PDF.
PDF, we're finding one term, okay? And then we would put in what, and what?
5.72 and 3.
Perfect, okay? Either way, you'll get it, and you should know how to do it by hand or with the calculator, because you will have a binomial probability or a binomial expansion of some sort on both papers. Pretty much everyone I've ever seen has a binomial expansion problem on paper 1, and there's almost always a binomial expansion on paper 2 as well. Okay?
The one that's like
So-
5 questions.